All right, we have this integral here from MIT Integration Bee 2022. It's just a little bit awkward, not that difficult, but having natural log inside the natural log and then having another natural log, that's going to be the tricky part. I think for my first step, I want to distribute it out, create this as two integrals. If I just multiply this into this, so like the first one, it's just going to be natural log x. For the second one, multiplying ln x times this, we end up with natural log x ln of ln x. Now, oftentimes with natural log, what's going to work well is integration by parts. So I'm going to do it using the DI method, and I'm actually just going to focus on this one over here. I think there's quite a few different ways to do this, so I don't really know if it would make that much of a difference, but let's do DI method on this one right here, where actually, and the thing about it is we usually don't want to integrate the natural log part. So what I'm going to do is I'm going to differentiate the whole thing and create a 1 to integrate. So how it's going to look, let's bring all this stuff down here, and we're just integrating 1. So then first, let's do this derivative using the product rule. So derivative of ln x is going to be 1 over x just times this. So I'll write it as this whole thing over an x. And then for the next part, we'll keep this. So we'll have ln x. Derivative of this is going to be 1 over ln x. Then chain rule, derivative of ln x is 1 over x. So let's write it this way. And then here, this integral is just going to be an x. So we'll have part of the solution right there on the diagonal. So we'll bring that part down. It's going to be just x, ln x, ln x. And then this whole line right here is going to be an integral, but we can break it up on the plus sign, break it into two integrals, just distributing in this x here. But when we do that, really what you can see is going to happen is like x is going to cancel here and here. In here, this ln x is going to cancel with this and just be a 1. So let's see what we have left. We're going to have this first part, which is going to be, with the x canceled, this is just going to be natural log ln x. And then, like I said, this part's a 1, so we'll break that out into another integral, just integrating 1. But I'm pretty much out of space. Let me get rid of the table and we'll create an integral of 1. And now all this is our answer to this first integral we underlined in red, but we still need to bring down this other integral in order to get to our solution. So let me just add that on at the end. And then here what we notice, this integral right here that we brought down is the same thing as this, and we're subtracting. So what's going to happen is that one is just going to cancel with that one. It tells you you could have done it a different way, doing like reverse product rule. That's the same kind of scenario when you get this cancellation. It's just kind of preference. Either way, you could do it that way. But then all we really need to do to finish it is just integrate 1, and that's going to be an x. So copying it down for my final solution on this, we'll bring this, change the order. We'll have x plus x ln x times ln x, add a plus c, and that's it. But now at this point, I'm noticing one mistake. Here on this one integral, on that line, there was a minus sign. I think this minus sign here needed to be distributed in. So I messed that up. Let's distribute that minus sign in right here like this. And now we can go to our solution, distributing the minus on the x. This is going to be a minus x. So putting it together for my final solution, we just get x ln x ln x minus x, add a plus c, and that's it. All right, there you go. Not bad. Just kind of a little bit of an awkward problem with integration by parts. Thanks everyone for watching. Have a good day.